Hello everyone, welcome back to my YouTube channel. I'm Nihati from Sri Venkateswara College of Engineering, and today I'm here with a video on the topic how to convert NFA to DFA using subset construction method, and that will be implementing by Python using Python. So in this video also we are taking a reference paper and then we're just explaining the reference paper. There's nothing more into it. So the thing is, in this paper they haven't given the code for how they are using Python to implement the conversion of NFA to DFA. So we'll just be seeing the theoretical part in this paper. No, there's no implementation. The referred journal is Non-Deterministic Finite Automata, that is NFA to Deterministic Finite Automata, conversion by subset construction method using Python. So this paper was presented by Kuldeep Vaya Dande, Krisha Patel, Nikita Punne, Shreyas Patel, Srishti Nikam, Sutanshu Patra, and from the Department of Artificial Intelligence and Data Science, Vishwakarma Institute of Technology, Pune, India. So this paper was published by them. So we'll be seeing about this topic. First of all, automata theory, it helps us understand how machines work and how it can solve problems and their applications. In finite automata, there is two types, that is deterministic finite automata and the non-deterministic finite automata. In DFA, if for any input symbol, there's only one transition state. It can go to only one state. In NFA, for any input symbol, it can go to more than one state. That is the major difference between DFA and NFA. So we'll just see what is written over here. Deterministic finite automata and non-deterministic finite automata are essential in this field, with DFAs having practical uses like content filtering and load balancing. Conversion between NFAs and DFAs is a common task, but for complex system, it is best handled by using algorithms. So this is what is given as the introduction in the paper. Now, this paper introduces a new efficient algorithm to convert NFA to DFA. Python 3 is used for implementation along with pandas for data handling. They're using two libraries, pandas for data sets to handle the data sets and Streamlit for building a friendly user interface. Okay, so for building a web interface, this method helps quickly convert large NFAs to DFAs, saving time and redundancy, reducing manual effort. Okay, so useful for students and researchers to study and solve automata related problems. This research covers literature on NFA to DFA conversion, description of the algorithm, challenges faced during this process. So this paper mainly contains these three topics. So first, before that, they have checked for the related works. First is enhanced efficiency in conversion. The improved algorithm minimizes unnecessary steps and speeds up the process by avoiding repeated calculations. So in one work, they have seen that this algorithm can minimize unnecessary steps and speed up the process by avoiding repeated calculations. Next is systematic DFA design. A structured method was developed to create DFA from NFA, focusing on binary string languages, that is strings made of zeros and ones. So then an algorithm was used to always produce a DFA and eliminate unreachable states. This is from another. All these are related work before they started, which they referred to before starting the research paper. Then handling null transition. C++ implementation handles complex cases by creating separate classes for NFA with null transitions. So these are the related work. Okay, so the next is the methodology. We'll be seeing what is the methodology they have adopted. They selected the project topic based on the group capabilities, domain knowledge, and achievable goals. Studied similar projects to understand past work and relevant methods. That is, they have referred to the past works also. Learn necessary tools, algorithms, and finalize the project flow. Divided tasks equally with each member completing the part. Use Python for coding NFA to DFA conversion, but the code part is not given in this research paper. Pandas for transition table and Streamlit for the website front end. So this is about the methodology they have adopted. The proposed system, it converts NFA to DFA within seconds using a user-friendly front end. So it basically this research paper is only about converting NFA to DFA using Python, and they have mentioned that the front end is user friendly also. Most existing systems are theoretical or complex to use, especially for the beginners. Our system simplifies the process with an easy to understand algorithm and a beginner friendly interface. So the algorithm they have given is easy to understand and the interface is also beginner friendly. Includes a feature to check if the given NFA is already DFA. So the first thing they even check if the NFA is already DFA, then we don't have to convert it into DFA. If it isn't, they have converted into DFA. The entire project, both backend and frontend, is implemented in Python. I've used only Python in this. So for flowchart, we'll be saying first, they're starting the program and then they will take input states, NFA states and paths as the input and save the data next. After saving the data, they're taking the NFA transitions, how from which state it is going. Then, after submitting the data, we'll check if the NFA is already a DFA. If it is already a DFA, we're just printing the NFA and then we'll stop end the program. If it is not a DFA, then we have to convert it into DFA, print the DFA, and then stop. So this is about the flowchart, how the program is. So now coming to the algorithm, the first step is to take NFA input. So we'll select the number of states and alphabets for the NFA. We are going to select this number of states for the NFA that is given. Enter the names of the states and alphabets, storing them in the list that is stored as list. Enter the transitions and final state after selecting the save option. So after saving the number of states, then we'll select the number of that I will enter the transitions and the final state. We'll press the submit button, and once all the data is correctly entered, this will store the NFA in a dictionary. The second step is checking if NFA is already a DFA or not. Check if the entered NFA is already a DFA using nested for loops and if-else condition. They're using for loops and if-else conditions to check if the NFA is already a DFA. If it is a DFA, then we can directly print the DFA. If it is not a DFA, then we'll go to step 3. So if it that is only given over here in the slide. If it is not a DFA, we'll proceed to step 3. If it is a DFA, skip the next part and print the entered NFA as a DFA. Now, step 3 is converting NFA to DFA. We'll convert the NFA that is already stored as a nested dictionary into a DFA. How? We'll add the initial NFA state to the DFA states list and store its path. So, the initial NFA state will be the initial DFA state. We'll copy the NFA transition into a DFA using a for loop. The NFA transition is copied into the DFA using for loop. Use while and for loops to find and add transitions for combined state in the DFA. NFA can have multiple transition state, but in DFA we can't do that. So we'll use while and for loop to find and add the transition to combined states. Keep the initial state the same and set DFA final state to any state containing NFA final state. We'll check the NFA final state, and in that we'll be giving, according to that, we'll be giving the DFA final state as well. Now, next we'll display the NFA transition table. When the user presses the submit button, display the NFA transition table. Convert the NFA dictionary into data frame using the data frame function and the transpose function from the pandas library. So this we have to convert. For making the transition table, we are using the data frame function and the transpose function from the pandas library. It will show the resulting NFA table. After that, step 5 is displaying the DFA table. After converting the NFA to DFA, display the DFA transition table. How? Show the initial state and final states of the DFA. Create the DFA transition table using the same method as the NFA. That is by using the transpose function and the data frame function. This will help in displaying the table. After that, they have just given the pictures of what did the website. There's no much codes and all, so we'll just see the pictures of how the website pages will just. So this NFA to DFA conversion website consists of the following two pages: about us page and home page. So the problem is that even the pictures aren't that clear. So to understand, we'll just be saying it. And the about us page, this page contains the details and contact information about the developers. That is a team, and it contains information about the team. So there's a welcome buddy and some few things, and the team members and their information. In the home page, we can enter the NFA details. After that, we'll enter the number of states first, and then even we can mention the final state of the NFA and how many paths it has. Okay, according to how many paths it has, the path transitions will come. After that, we'll save the data, and then it will go to the next page. That is, we are entering the NFA details. So the first thing we enter is the number of states. Then we'll enter if there are three states. According to that, the state names also we can enter. For three states, they have entered A, B, C, and the final state also they have mentioned that as C. After that, the number of paths they have given as two. So two paths are shown over here. That is path one and path two. So the path one symbol, they're taking zeros and ones are the input symbols that are taken for this NFA problem. So here what is given is this represents the state of home page where we can increase or decrease the number of states and paths according to the chosen number. The text box to enter the names of states and paths are found. A text box for entering the final state or states of NFA is also there. After entering all the information, we can select the save option. There's a save option over here. Save option. Save the date to save the data and generate the text box to enter the transitions of NFA. So this is the page that we have already seen. Next, the next page, what is coming over here is the enter transition page. So here we have given there are two paths and there are two paths, that is zeros and ones, and there are three states. And C is the final state is given already. Now here we can see that end state from A traveling through path 0. So if 0 is the input from A, where will it go to is asked. So it's going to itself, that is the self loop. Next one is end state from state A traveling through path 1. So if 1 is given as the input, the state it will travel to A and to B. So it is a self loop to A again and to B if one is given. And then here there's no path, that we're just leaving it as null. These two also are left as null because there's no path. Then end state from state B traveling through path 1. So from B to C, it is 1, input is 1. So that is given over here. And then we'll press the submit button. So what is written over here is this shows the state of home page after selecting the save option. Here we can see that the text box to enter the transition of from the NFA. If the transition is null, then leave it blank. So these three are left blank because the transition is null. And enters the states leaving a single box white space. So if there are more than one state for transition, enter the states leaving a single white space. So there's a single white space between A and B, and it is entered in the same box itself. After entering all the transitions, click onto the submit button. Now it will display the NFA and DFA table. So this is how the NFA transition table is formed, and this is the DFA transition table. Also, the initial state of DFA and the final state of DFA is also given over here. This figure represents the state of home page after selecting the submit button when the DFA is not same as the NFA. So here DFA is not same as the NFA, so it's showing the NFA and DFA table. Here we can see the transition table of the entered NFA and the results of the program. That is the DFA transition table. Its initial state and final states are also mentioned over here. Next. So if NFA is already a DFA, what happens is this NFA is already a DFA is written and only the DFA transition table is formed. And even the initial state, final states of the DFA is mentioned. The NFA transition table is not shown over here. It represents the state of home page after selecting the submit button when NFA is already a DFA. Here we can see the transition table of the entered NFA and this entered NFA. So NFA is already a DFA. So this is basically NFA itself. So and its initial state and final states as it is only the DFA. So now coming to the conclusion, this website is made for converting NFA to DFA and implemented the algorithm using Python 3. It is user-friendly, allowing even beginners to efficiently convert NFA to DFA within seconds, saving time and reducing errors. So the limitation of this implementation is it cannot directly convert NFA with epsilon transitions to DFA. Manual conversion is needed first. That is one limitation. It generates the DFA transition table but cannot create DFA state diagram. So only the transition table is created. We cannot create a DFA state diagram. Now, future scope enhancements, what can be done in future, we'll see. This could include additional conversions like NFA to regular expression and DFA to regular expression. state diagrams for NFA and DFA, and detailed conversion steps. These could be created in future. This website could be deployed publicly with mobile apps or dynamic features for improved user experience. So this is all about this topic, and this paper is in this paper. So if you like the video, please do like, share, and subscribe. And thank you.